All right, everybody. So we're starting with number 8 of the exam. Welcome back. Welcome back. All right, so we're starting with number 8. So number 8 says, which sequence of change in rock types occur as shale is subjected to increasing heat and pressure? All right, so when I'm taking a look, where is shale? Where is shale? I'm looking for shale, and we know that shale is a sedimentary rock. And they want to know, according to the question, it says which sequence of change in rock type occurs as shale is subject to increased heat and pressure. So when you have a sedimentary rock that goes through increased heat and pressure, it turns into another type of rock. The rock that it turns into, right, is a metamorphic rock. And how do I even know this? If you take a look at page 7, we see what happens to shale when it goes through metamorphism. When it goes through metamorphism, it turns into slate. And so one of the things you'll notice, that's one of the reasons why all of these choices, it starts off from shale. Well, it starts off from shale, but there's only one choice that goes from shale to slate. And we see it as choice B. All right. And once again, because it says it right here, low grade metamorphism shale to slate. Now, if you wanted to keep on going to see, okay, how else do we know that it goes through, starts from slate and it turns into other types of rock, you see this point in the key right here where it says type of metamorphism, and you see how the arrow is pointing down and it says as heat and pressure increases. That lets me know that the further down I go to the list, from slate to phyllite to schist and to gneiss, the further down that I go, the more pressure and heat increases. And so that's why if you look at choice 2, you're going to see slate, phyllite, schist, gneiss, from low grade metamorphism all the way to high grade metamorphism. So it's in order of increasing heat and pressure. And so that's the reason why when you take a look here, you will see that it goes from shale to slate to phyllite, schist, and gneiss. So choice B. Let's take a look at number 9. So number 9 says there are 9 rock samples were classified into 3 groups shown in the table below. So they give us group A, group B, and group C. This classification system was most likely based on what? So let's take a look. Granite, rhyolite, and gabbro. I've seen these rocks before. When I look through my reference tables, I see granite is here. Let me move on up. Let me move up a little bit more. Sorry. Granite is here. Rhyolite is here. Gabbro is here. What do they all have in common? It looks like they're all igneous rocks. When I take a look, shale, sandstone, and conglomerate. Well, shale, sandstone, and conglomerate. Let's see, shale, oops. Shale, sandstone, and conglomerate. What do they have in common? They're all sedimentary rocks. I think I'm starting to see the pattern. Now the last group C, if you look on your paper, the 3 rocks it says is marble, schist, and gneiss. What do these 3 have in common? They're metamorphic rock. So therefore, when I go back to my exam, so I know this is an igneous rock. I'm just going to label I for igneous. This is a sediment. These are all sedimentary rocks. I'm label S for sedimentary. And this is metamorphic rocks. I'm gonna label M for metamorphic. So they're classified, separated, igneous, sedimentary, and metamorphic rocks. What is the difference between the three? It's all about the way they are formed. If you look at page 6 of the reference tables and you go to the rock cycle chart, all these three types of rock go through different processes into how they're formed, right? Sedimentary rocks, compaction, cementation. A metamorphic rock has to go through metamorphism, heat and oppression. Igneous rocks, there's melting that occurs and then solidification, cooling. So all three of these rocks are created differently, and that's why they're set up apart that way. And so that's why the correct answer is choice C. All right, let's take a look at number 10. Let's take a look at number 10. So number 10 says the element silicon is used in the production of cell phones. Which mineral could be a possible source of this silicon? When I'm looking at this problem, all right, I know that the element is silicon, Si, and is used in the production of cell phones. This is something that's going to help me. What mineral could be a possible source of this silicon? So there's only one page of the reference tables that focuses on minerals. It focuses on minerals and what minerals are made up of. So when we take a look, let's see, we're going to go to page 16. All right, we're going to go to page 16. And so therefore, I'm going to look, and they gave us 4 minerals: calcite, halite, olivine, and quartz. All right, so which mineral contains silicon? So when you take a look, you see how silicon is located right here. It has the chemical symbol Si. So I'm first going to look for which minerals have Si, right? So olivine has Si, quartz has Si. What else? Calcite does not have Si, and halite does not have Si. So we know it's either olivine or quartz, 2 choices. Now the other part of the problem, remember that it stated the fact that it's a production, the use of cell phones. So when I go back to my reference tables, olivine use, I see, you look under the category of use, right? We look under the category of use, olivine's use is furnace and bricks and jewelry, furnace, bricks, and jewelry. Quartz use, glass, jewelry, and electronics. So it can't be olivine because it says right here for quartz, and I'm going to clear everything up. It says right here, the use for quartz is electronics. So therefore, it definitely could be used for the production of cell phones because cell phones are, or ours is an electronic. All right. So therefore, that's why it's going to be choice D. It's going to be choice D. All right. Let's take a look at number 11. Let's take a look at number 11. So number 11 states, base your answers to the following question on the diagram below, which represents a rock composed of cemented pebbles and sand. This rock should be classified as what? There's something in this problem that's going to give me a clue as to what type of rock it is. What is it? It says a rock composed of cemented pebbles and sand. This word cemented, I've seen it before when I'm talking about different types of rock. Only one type of rock where there's cementation that occurs. When I look on my reference tables, I see it right here. You see the word cementation. What arrow is it pointing to? A sedimentary rock, people. A sedimentary rock. So I already know that this is a sedimentary rock. So when I take a look, I know I can cross out which ones. An intrusive igneous rock can't be that. An intrusive igneous rock. Sedimentary and sedimentary. What is the difference between bioclastic and clastic? All right. The difference between a bioclastic and a clastic rock is in the prefix, right? Bio means life. And so that lets me know a bioclastic sedimentary rock is a sedimentary rock that may have organic remains in them. They tell us the only thing that's in this rock is pebbles and sand. It is not, doesn't have any organic material on it. So if it's a pebbles and sand, right? If it's a non-bioclastic rock, then therefore is going to be a clastic sedimentary rock. You can even check on your reference tables what rock is made up of pebbles and sand. When I look at page 6, when I look at page 7, I apologize, right? Pebbles and sand, a rock that's made up of cemented pebbles and sand. I see pebbles embedded in sand, and it could be conglomerate or breccia, but most importantly, clastic igneous rock. Sorry, clastic sedimentary rock. And so that's why the answer is, when we take a look, choice D. Let's take a look at number 12. Number 12, it says, the table below shows the chemical formulas for 4 rock-forming minerals. Which mineral contains the 2 most abundant element by mass in Earth's crust? If we take a look, let's take a look at our reference tables where we can find out which are the 2 most abundant elements by mass in Earth's crust. What page am I looking at? I'm going to go to page 1. Why? Because they're going to tell me the composition. Remember, the word composition means what something is made up of the Earth's crust, the chemical composition of the Earth's crust by mass. And there are 2 elements that make up majority of the Earth's crust: oxygen and silicon, O and Si. So therefore, that's going to play a role when I'm going to pick my choice. So that means that I need to pick a mineral here that contains Si and O. When I take a look, chalcopyrite, I'm sure I'm butchering that name. I see S but no O. All right. Phyllite, I see Si. I see Si and O. I see silicon and oxygen here. Apatite, I see oxygen, but I do not see silicon, so it can't be that. Barite, I see oxygen, but I don't see Si. Remember, the chemical symbol for silicon is Si. So the correct answer is going to be choice B, phyllite, because it has silicon and oxygen, Si and O. And moving on to number 13. All right, number 13. So I take a look at number 13, and it states, which 2 minerals have cleavage planes at right angle? What page I'm gonna look at that has detailed distinguishing characteristics of minerals? I'm going to go to page 16. All right, cleavage planes at right angles. And so when I take a look, I'm going to go to distinguishing characteristics. All right, that's where it's going to tell me how exactly are the angles pretty much of how the minerals have cleavage. All right. So which two minerals have cleavage planes? So automatically, it has to be a mineral that actually has cleavage, right? So let's take a look at the first option. Biotite mica and muscovite mica. Do they have cleavage? Let's take a look. Biotite mica and muscovite mica. How can you tell if they have cleavage? You'll take a look. All right, it says it right here. So biotite mica, they have cleavage. They have biotite mica and muscovite. All right. When I'm looking, they both have cleavage, but I see flexible and thin sheets, and I see flexible and thin sheets. So nothing about cleavage planes at right angles. All right. Let's take a look to sulfur and amphibole. Sulfur and amphibole. So when I scroll down, sulfur and amphibole, sulfur, sulfur. I'm looking for sulfur. All right. So automatically, sulfur is fracture. It has the check fracture. So automatically, it cannot be sulfur because it has fracture. If you take a look, if I scroll, you see, it has the fracture checkbox on it. So automatically, it can't be choice 2. Take a look. All right, so it cannot be choice 1. It cannot be choice 2. We're gonna look at quartz and calcite. Let's look at quartz and calcite. So quartz and calcite. All right. So I see quartz, calcite. Okay. So starting off with calcite. Calcite is cleavage. All right. Cleavage. So that's a possibility. Let me look at quartz. Quartz is fracture. Fracture, so it can be quartz. Quartz has a fracture check. All right. And so the last one is highlight and pyroxene. So highlight, choice 4, highlight and pyroxene. So when I take a look, highlight has a cleavage check and pyroxene has a cleavage check. A right angle is 90 degrees. Remember, a right angle is 90 degrees. So therefore, cleaves in 2 directions. I see that. And for highlight, it says it has a cubic cleavage. If there's something you know about a cube, right? A cube has right angles. If you ever seen a cube has right angles on all sides. And so that's why choice 4 is the correct answer. So I take a look, it ends up being choice 4, highlight and pyroxene. You can look at the next videos for the rest of the questions.